something unusual happened beneath Ethiopia in 2005. In less than a week, a roughly 60-kilometer-long section of the rift opened, in places by several meters. It wasn't an earthquake tearing Africa apart in one catastrophic moment. Something deeper was happening. Magma had forced its way upward, pushing the crust apart from below. And that matters because this region sits inside the East African Rift, where the African continent is slowly being stretched. But here's where the story becomes strange. A rift does not have to become an ocean. Some continental rifts eventually stop. The crust stretches, weakens, and then somehow manages to hold together. Others continue until the continent breaks apart and new oceanic crust begins to form. So the real mystery isn't whether Africa is moving. We already know it is. The question is what happens when the crust can no longer absorb the strain. Because beneath East Africa, scientists may be watching that question unfold in real time. A continent does not tear apart like glass. The process is slower, deeper, and far more complicated. As tectonic plates pull away from each other, the continental crust stretches and becomes thinner. At the same time, hot material rises from deeper inside Earth, and magma can move upward through the weakening rock. One of the best places to see this process is the Afar region of Ethiopia. Here, three major tectonic plates meet. To the north, the Red Sea is already opening. The Gulf of Aden is also spreading apart. Farther south, the East African Rift is still in an earlier continental stage. That means one region contains different stages of the same geological process. It gives scientists something rare, a natural comparison. They can study places where continental crust is still being stretched and compare them with regions where the crust has already given way to oceanic spreading. But that comparison raises a deeper question. If some parts of the system have already progressed toward an ocean, why haven't all of them done the same? What determines whether a rift succeeds or quietly dies? East Africa gives us evidence for both possibilities. In parts of the Turkana Rift, seismic studies indicate that continental crust has become unusually thin, roughly 13 kilometers in some areas. That is remarkable because continental crust is normally much thicker. The crust here is not simply being pulled sideways. It is being stretched, weakened, and deformed from within. Geologists sometimes describe part of this process as necking, when a section of continental crust becomes progressively thinner as the plates continue moving apart. But thinning alone does not guarantee that a new ocean will appear. Some rifts stop progressing before the continental crust fully breaks apart. And East Africa shows signs of both outcomes. The same broad tectonic forces can produce very different results across a single continental rift. So the mystery becomes even more specific. Is East Africa approaching the point where the crust stops merely stretching and starts giving way? There is one event that shows just how dramatically this process can accelerate. In 2005, the Dabahu region of Ethiopia experienced a major episode of rifting. Most of the deformation could not be explained by earthquakes alone. Instead, magma injected through a deep vertical sheet of rock, a dike, forced its way through the crust and helped open a roughly 60-kilometer-long section of the rift. In places, the ground moved several meters in less than a week. For a geological process normally measured in millimeters per year, that is astonishing. And it reveals something important. The continent does not need one enormous surface crack to begin breaking. The process can happen from below. Magma can enter the crust, push it apart, and weaken the rock around it. Repeated episodes can gradually transform the structure of the continent. This is why the East African Rift is so important to scientists. It provides a rare opportunity to observe the mechanisms that can eventually carry a continent from stretching towards separation. But there is still no guarantee that the process will finish. The real question is what happens if these forces continue for millions of years. The most important question, then, may not be whether Africa will split apart. It is whether we are already seeing the earliest stages of something much larger. Across East Africa, the crust is stretching, thinning, and being weakened from within. In places, magma has already forced its way upward and opened major sections of the rift. Most of this happens too slowly to notice, but the evidence shows that the process is real. And if the rifting continues for millions of years, the outcome could be extraordinary. Continental crust could become too thin to hold together. Magma could continue rising. New oceanic crust could begin forming. Eventually, water could occupy the space where land exists today. That future is not guaranteed. Some rifts stop progressing. Others may develop in ways scientists cannot yet predict. But that uncertainty is what makes East Africa so fascinating. Because the landscape beneath our feet may not be permanent. We could be looking at the earliest stages of a future ocean being born. The explosion isn't the story. The transformation is.